Welcome, YouTubers. In today's video, I'm going to be working out 6 practice test questions involving volume that should closely mirror what you should expect to see in both the arithmetic reasoning as well as the mathematics knowledge subtest of the Armed Services Vocational Aptitude Battery, that is the ASVAB, as well as the pre-screening Internet Delivered Computer Adaptive Test, that is the PiCAT. Of course, in order to get the most out of this video, you'll want to pause the video after I read a practice test question, attempt to work out that practice test question on your own, and then resume playing the video to check your solution. As a quick reminder, you're not permitted to use a calculator or a reference sheet on the actual ASVAB and PiCAT, so as you work your way through these 6 practice test questions, try not to use any of those resources. Finally, I want to say this. If you can answer at least 4 out of these 6 practice test questions correctly, chances are you know enough about volume to pass the ASVAB and PiCAT already, and for that reason, I would recommend that you study something else in the meantime. If, however, you struggled with these practice test questions, I would encourage you to do 2 things. One, I would encourage you to find my playlist called Geometry Review for the ASVAB and PiCAT. It has more than 500 practice test questions, and it covers all the topics in geometry that you need to know for the ASVAB and PiCAT, including everything you need to know about surface area and volume. Of course, I'll put a link to my geometry review playlist in the description of this video. At the same time, I would also, download a copy of my free reference sheet for the ASVAB and PiCAT. It has all the formulas you should consider learning and memorizing for the ASVAB and PiCAT. And one way you can go about learning those formulas is simply to take my reference sheet and copy it down in your own handwriting. Likewise, I'll put a link to my free reference sheet in the description of this video as well. And with all those things finally being said, let's go ahead and get started with this video. This first question says this: what is the volume of a shoebox that has a length of 10 inches, a width of 7 inches, and a height of 5.5 inches? So the first thing you have to realize in order to answer this question is that a shoebox is a rectangular prism. And to find the volume of a rectangular prism, we use this formula: volume equals length times width times height. Of course, we were given all those values in this problem. We were told specifically that our prism has a length of 10, so L is 10, a width of 7, so W is 7, and a height of 5.5, so H is 5.5. Let's go ahead and plug those things in accordingly. This becomes 10 times 7 times 5.5. 10 times 7, of course, is 70, so this becomes 70 times 5.5. So to find the volume of our shoebox or our rectangular prism, we have to do this math right here, 70 times 5.5. And this is where some people would get stuck. So for that reason, I'm going to take a few minutes and work this off to the side. We have 70 times 5.5. All right, so we're multiplying, in other words, a whole number by a mixed number. Well, as it happens, I only have a video on multiplying fractions. And if you watch that video, you would know that when you have a scenario like this, what you want to do is convert your whole number of 70 to a fraction by placing it over 1. So this becomes 70 over 1 times. And then you want to convert your mixed number into an improper fraction by doing this. Your denominator of 2 is not going to change. The numerator is going to be 5 times 2, which is 10, plus 1, which is 11. All right, so now, as you can see, we're doing nothing more than multiplying the 2 fractions, notably 70 over 1 times 11 over 2. Of course, at first glance, this seems like a lot of work. That said, you can make this even easier by cross-reducing. You could say 2 goes into 2 one time, 2 goes into 70 35 times. All right, so what we have here is 35 over 1 times 11 over 1. 35 over 1 is just 35. Again, 35 divided by 1 is 35. 11 divided by 1 is just 11. So as you can see, 70 times 5 and 1/2 is the same thing as 35 times 11. Of course, we'll do that math off to the side so as not to make any mistakes here. 5 times 1 is 5, 3 times 1 is 3. Before we start multiplication with this 1, we have to bring in a 0 placeholder. 1 times 5 is 5, 1 times 3 is 3. Let's add these together. Uh, 5 plus 0 is 5, 5 plus 3 is 8, 3 plus nothing is 3. So the volume of our shoebox that has a length of 10, a width of 7, and a height of 5.5 is 385 cubic inches, which is answer choice C. All right, so number 2 says this: the area of the floor of a room is 12 square feet. If the total volume of the room is 96 cubic feet, then what is the height of the room? All right, so in this case, we were given some information, notably that the volume of our room is 96 cubic feet. And in addition, we were told that the area of the floor of our room is 12 square feet. So for a problem like this, it might be helpful to quickly make a sketch if you need it. And of course, we're dealing with another rectangular prism, so let's make one of those very quickly. All right, so what are the parts of a rectangular prism? We have length right here, width right here, and height right here. To find the volume of a rectangular prism, as we saw in the first problem, it's length times width times height. Well, we were told that the area of the floor of this room, which I'm going to shade in red here, is 12 square feet. How do I find the area of that floor? Well, that floor is nothing more than a rectangle. So to find the area of our rectangular floor, we would do length times width, and we know its area is 12 square feet. Well, let's take a look at this volume formula. What is this right here? This is the area of the base of our rectangular prism. So in place of length times width here, we can simply plug in 12. So this becomes volume equals 12 times h. And what's more, we also know that the overall volume of our rectangular prism is 96. So in place of v, we can substitute in 96. So this becomes 96 equals 12 times h. Of course, now we're just solving for h because that's what this question is asking. What is the height of the room? To get h by itself, we're going to divide both sides of this equation by 12. In doing so, we get a cross out here. This leaves us with h on this side. 96 divided by 12 is 8. So the height of our room is simply 8 feet. All right, so the answer to this one is B, of course. All right, so number 3 says this: a gas truck can fill a gas tank at the rate of 320 cubic inches per minute. If a rectangular gas tank is 10 inches long, 8 inches wide, and 12 inches tall, how long will it take the gas truck to fill this tank? So to answer this question, the first thing we have to figure out is what is the volume of this rectangular gas tank. Again, we have a rectangular gas tank, which means it is a rectangular prism. To find the volume of a rectangular prism, it's going to be length times width times height. And of course, this problem told us what all those values were. Specifically, it said the length of our gas tank is 10 inches, so L is 10. Its width is 8, so W is 8. And its height is 12. So let's plug those in accordingly. This becomes 10 times 8 times 12. All right, let's keep working this out. 10 times 8 is 80, so this becomes 80 times 12. And of course, I'm going to work this off to the side so as not to make any mistakes. We have 80 times 12. 0 times 2 is 0. 8 times 2 is 16. Before we start multiplication with that 1, we have to bring in a 0 placeholder. 1 times 0 is 0. 1 times 8 is 8. Add these together. 0 plus 0 is 0. 6 plus 0 is 6. 1 plus 8 is 9. So the volume of our gas tank is 960 cubic inches. All right. Well, this problem tells us that this truck can fill up this gas tank at a rate of 320 cubic inches per minute. So, to figure out how long it's going to take this truck to fill up this gas tank, we're going to take the volume of our gas tank, notably 960 cubic inches, and we're going to divide that by, that should be an N, not an M, the rate at which the gas truck fills up the gas tank, which is 320 cubic inches. All right, so by doing this division, notably 960 by 320, we'll figure out how long it takes to fill up this tank. Of course, we can cross out these units now, and we can also cross out these corresponding zeros. So we're left with 96 over 32. And if you prefer it, you can do this as long division off to the side, notably as 96 divided by 32. Well, let's think about this one. This math is actually very easy to do. 30 times 3 would be 90. So 32 times 3 should be 96. So let's work that off to the side to confirm it. 32 times 3. 2 times 3 is 6. 3 times 3 is 9. So 32 times 3 is exactly 96. 96 minus 96 is 0. We hit a 0, so we know we're done doing this long division. In other words, it's going to take 3 minutes to fill up this gas tank with this gas truck, which is answer choice C in this case. All right, so number 4 says this. A rectangular tank is 9 feet wide and 10 feet long. It can hold up to 810 cubic feet of water when full. If the tank is only filled to 1/3 of its height, determine the height of the water in the tank in inches. All right, so in this case, we're working with another rectangular tank. So we know that we're going to be using the formula to find the volume of a rectangular prism. Of course, that formula is volume equals length times width times height. And of course, we were given some of these values in the problem. Specifically, we were told that the width of our tank was 9 feet, so W is 9, and it has a length of 10, so L is 10. In addition, we were told that when it's full, its volume, or V, is 810 cubic feet. That said, we want to know its height, or H, when the tank is only 1/3 filled. All right, so the first thing we want to do is take all the values that we were given and plug them into this formula. Again, we know it has a volume of 810 cubic feet. So in place of V here, we're going to put 810. We know it has a length of 10, so we'll put 10 there, and a width of 9 there. We don't know its height when it's full, so we'll leave that as H. Clearly, we can find the height of this tank when it's full by solving this equation for H. So let's go ahead and do that. 10 times 9 is 90. This becomes 90 times H equals 810. All right, to get H by itself, we're going to divide both sides of our equation by 90. In doing so, we get to cross this out, leaving us with H on this side. This math is actually much easier to do than you think. You can cross out these corresponding zeros. 81 divided by 9 is 9. So H in this case is 9. In other words, when the tank is full, it has a height of 9 feet. Well, in this case, it says right here, if the tank is only filled to 1/3 of its height, determine the height of the water in the tank in inches. Well, if it's full, it's 9 feet high. So we'll take 9 and we'll multiply that by 1/3 to determine its height when it's only filled to 1/3 of its height. This is actually very easy to do. Again, we're multiplying a whole number by a fraction. To proceed, we want to make 9 a fraction by placing it over 1. This becomes 9 over 1 times 1 over 3. When you multiply two fractions, you just multiply straight across. This becomes 9 times 1 over 1 times 3. 9 times 1 is 9. 1 times 3 is 3. 9 divided by 3 is 3. So the height of our tank when it is filled to 1/3 of its full height is B, 3 feet. All right, so number 5 says this. Phil has 2 cardboard boxes. The height of the second box is half the height of the first box. The lengths and widths of the boxes are the same. If the first box has a height of 10 inches, a width of 5 inches, and a height of 10 inches, then how much more volume does the first box have than the second box? So for this problem, we're comparing the volume of two cardboard boxes. As it happens, cardboard boxes are in the shape of rectangular prisms. So we can say the volume of our first box, V of 1, is length times width times height. And we're going to be comparing that to the volume of our second cardboard box, which I can call V of 2. Of course, it's a rectangular prism, so it's going to be length times width times height. All right, let's go through this problem and see what information we were given. We were told that the first box has a length of 10, so L is 10, a width of 5, so W is 5, and a height of 10. So let's go ahead and plug those values in for our first box. Again, that's 10 times 5 times 10. Let's see what information we have about our second box. We were told that the lengths and widths of the boxes are the same. If our first box had a length of 10, that means our second box has a length of 10. If our first box had a width of 5, that means our second box had a width of 5. That said, it says the height of the second box is half the height of the first box. Well, the height of our first box was 10. The height of our second box is half of that. So if you need to, you could do this off to the side. We're going to do 10 times 1 half. 10 times 1 half, you should know, is 5. So the height of our second box is 5. Now we have enough information to figure out how much more volume the first box has than the second box. Let's go ahead and work this out. 10 times 5 is 50, of course, so this is 50 times 10. 50 times 10 is 500. All right, let's do the same thing over here. 10 times 5 is 50, and 50 times 5. If you can't do that in your head, you can always do it off to the side. We have 50 times 5. 0 times 5 is 0. 5 times 5 is 25. So 50 times 5 is 250. So the volume of our first box is 500 cubic inches. And the volume of our second box is 250 cubic inches. How much more volume does our first box have than our second box? Well, that's going to be 500 minus 250. You should know that's 250 without having to work that out, but if you need to, we can do this by hand. 0 minus 0 is 0. 0 minus 5 we can't do, so we're going to borrow. This is going to become 4. This will become 10. 10 minus 5 is 5. 4 minus 2 is 2. So our first box has 250 more cubic inches of volume than our second box, which has half the height of our first box. All right, so number 6 says this. Jamie just bought 2 boxes. The first box is square with each side measuring 10 units and is 4 units high. The second box is rectangular and has twice the volume of the square box. If the height of the second box is 5 units and its width is 10 units, what is the length of the second box? So as we did in the previous problem, we're going to be comparing the volume of 2 boxes. For that reason, we want to set up our problem just like the previous problem. The volume of our first box is going to be length times width times height. The volume of our second box is going to be length times width times height. What do we know about our first box? Well, according to the problem, it has a square base with each side measuring 10 units. Well, the base of a square box is length and width. So in other words, we know the length of this first square box is 10 and its width is also 10. And right here it says its height is 4. So for our first box, we know it has a length of 10, a width of 10, and a height of 4. And in case you can't see that, let me draw that real quick. All right, here is the base of our box, and as you can see, it's in the shape of a square. This is its length. This is its width. Again, squares have equal sides. We're told that each side of this square box measures 10. So this is 10 and this is 10. Of course, we were told it has a height of 4. All right, so that's how I know its length and width are 10. What do we know about the second box? We're told that it has twice the volume of the square box. Its height is 5, so h is 5. Its width is 10, so w is 10. And we don't know its length. So we're going to be solving for L. So this becomes L. We don't know what L is. Has a width of 10 and a height of 5. So we're going to have to use information about the volume of this first box to answer a question about the volume of the second box. All right, so let's go ahead and do that. How do we find the volume of the first box? It's 10 times 10 times 4. Again, 10 times 10 is 100, times 4 is 400. So we know the volume of our first box is 400. Well, we were told in this problem that our second box has twice the volume of the first box. So to find V2, we're going to take the volume of our first box, notably 400, and we're going to multiply it by 2. You should know that 400 times 2 is 800. In other words, the volume of this second box is 800, and that means we can go ahead and replace V2 right here with 800. All right, so clearly we have enough information to now solve for L, the length of the second box, because we can do this. 800 equals L times, what is 10 times 5? That is 50. If we divide both sides of this equation by 50, we'll get L by itself. This crosses out, leaving you with L on this side. We can cross out these corresponding zeros, and this should be pretty easy to figure out. 40 divided by 5 would be 8. Therefore, 80 divided by 5 is going to be 16. So the length of this second box is 16 units, which is answer choice D. If you wanted to, you could have worked this out using long division, notably as 80 divided by 5. 5 doesn't go into 8 except for one time. 5 times 1 is 5. 8 minus 5 is 3. Drop down this 0. 5 times 6, of course, is 30. 30 minus 30 is 0. All right, so that's how I got 16 there. All right, so that is it for this video. As always, I hope you found it helpful. And as usual, you're more than welcome to leave feedback in the comment section below. As I said at the beginning of this video, if you can answer at least 4 out of these 6 questions correctly, then you should be fine on test day. Otherwise, I strongly encourage you to work through my playlist called Geometry Review for the ASVAB and PiCAT. Of course, a link to that playlist is in the description of this video. If you want to help my channel out, you can do one of 2 things, of course. You can 1, subscribe to my channel if you haven't done so already. And 2, you can share links to my videos, including this video, on social media, including on Facebook and Twitter. And on that note, I'm going to go ahead and cut you loose. Konnichiwa.